Hey guys, Mr. Bowman here. Today's learning objective is in white, and we are learning to calculate the area of a rhombus or kite. So those are two new words or two new shapes that we're looking at, and I'm just going to explain what each of them means. We're going to go through the shape and their physical characteristics, and then I've got 4 examples on the right, 2 of each. We're going to go through both combinations, and then we'll get into heaps of practice after that. So as you can see from the shapes on the right, all of these kind of look a bit like diamonds. But there is a subtle difference between the two. So a kite and a rhombus, they both go in like that, and then they both go out like that. So this one that I've just drawn, what you can see is this half is a lot longer than that half of the shape. And that's where the corners intercept each other from the across. So the fact that one side is bigger than the other, that's what makes this shape a kite. And if you think about kites that you see often in the sky, they do take that shape. When they are the exact same, so I'll just try and draw another one here. So when you pop that in the middle, when the half going from the intersection to the end, the same, when they are equal to each other, that is what makes a shape a rhombus. And what we're trying to do in today's video, we're going to learn how do we find the area of these shapes. They do have quite a similar formula, so that's why we're grouping them together. So the area formula, I'm going to write it at the top. I'll write it down the middle actually. So the area of a rhombus or a kite is equal to 1/2 of A times B. And I'll show you where A and B is. So A and B are the corner to corner lengths. So up and down would be A, across would be B. And then in the kite above, up and down would be A, and across would be B. So hopefully that makes sense. So now that we've got an idea what's the difference between a kite and a rhombus, we're going to go through the 4 examples. We're going to identify whether or not each one is a kite or a rhombus, and then we're going to go through and calculate the area of each of them. So we'll just label all the question numbers. So we've got 1 up there, then we've got 2, then we've got 3, then we got 4. So let's start off with number 1. So is it a kite or a rhombus? And a kite or a rhombus, I always look at the middle. So we're going to go down the middle here. Is it the same either side of that midpoint? And in our case, it looks like it is the same. And the idea that it's the same suggests that it is a rhombus. And then from that, we can go ahead to calculate the area. So the area is equal to 1/2 of A times B. So A would be how much it is up and down, which is 8. So that's going to be 1/2 times 8. And then B is how much it goes across, which in our case will be 12. And then when we calculate that, we can just put that in our calculator. So we've got 0.5 times 8 times 12. That gets us to 48. And I'm not sure what units these are, so I'm going to write units squared. So that's the first one done. The second diagram that we're going to look at, we need to figure out, is it a rhombus or a kite? So if we go across it, down there, is it the same distance both sides? And in our case, it is not. And that is evidence that it will look like a rhombus. And we can see here, this side here is 5 centimeters, that side there is 3 centimeters. So that shape there is a kite. And the same formula applies for kites. So the area is equal to 1/2 of A times B. So let's have a look from corner to corner. How long is this side here? So that looks like it's going to be 5 plus 3, which gets us to 8. That's going to be 1/2 times 8 times, and we go across the other way, that's going to be 3 plus 3, which will be 6. And again, let's put that into our calculator. So we've got 0.5 times 8 times 6, and that there gets us to 24 units squared. We're now going to move on to question 3. So same deal, is it a kite? Is it a rhombus? So we're going to go down the middle and let's have a look. Is it the same length to the left and to the right? In this case, it looks like it is again. They look like that goes down the middle. So that means it is another example of a rhombus. And then the formula for a rhombus, same again, 1/2 of A times B. That's going to be 1/2 times 16 times 12. And let's put that straight into our calculator. 0.5 times 16 times 12. That gets us to 96 centimeters squared. And actually just realized the one above, that should be centimeters squared as well, because we were given those units. And the last shape, same steps. Is it a rhombus? Is it a kite? So let's go down the middle, corner to corner. We can see this side here is 2 feet. This side here is 6.5 feet. That tells us they are unequal, which is what a kite looks like. And same steps with the area formula, 1/2 of A times B. So that is going to be equal to 1/2 times 8.5, because it's the 2 over here plus the 6.5 over here. And then we're going to times by 8, the 4 along there and the 4 down the bottom. We then put that into a calculator, so 0.5 times 8.5 times 8. All of that comes to 34 feet squared. So hopefully you found today's video useful. We looked at how to find the area of a rhombus and how to find the area of a kite. Hopefully you can tell the difference between the two, and hopefully you've got that formula, area times 1/2 of A and B, useful. Okay, let's get into heaps of practice now.